Thunderbeast is one of those companies that I've been a fan of for a really long time, and that's partly because of their manufacturing process. I did a tour of Thunderbeast's manufacturing facility while I was out at Wyoming at KRG Extreme.
This is a 3-turret, dual spindle, 12-axis lathe. So this is processing 2 parts at one time. So you've got solid bark stock coming in from the left, and this is 2 spindles that are each processing a part. So that's actually a probe that's measuring the part that's on the main spindle and qualifying it if it's good or bad. Cuts half the part over here, and then the sub-spindle grabs it, parts off, and then while it cuts the next half apart here, it finishes the first part. It will make its own wear offsets. We have tool monitoring on this system so that if a tool load goes too high, it calls up a redundant tool and keeps running.
What is all the green?
So green is good. Each row is 1 part.
So if there was red on this, then one of those parts would be bad.
There's a scrap part in the last 100.
It all appears to run on some form of electricity.
That is correct. Electricity and compressed air.
And this is one of the parts that just came out of this.
Yep, so that's the
That
part.
would be a baffle.
Yep. So that is the core center of a Magnus.
Where does this go from here?
So from here, this basically travels back in the shop through those doors. That's welding. So we weld everything with a laser welder, but basically a stack of these gets welded up. From there they come back, and we're gonna go back here.
So the baffle went back there.
And here's that can.
All of those baffles are then welded using that laser welder into this. How long does it take to do all these welds generally?
So that whole can takes less than 4 minutes with our laser.
This only took 4 minutes.
Yep, 4 minutes to weld the whole can. That lets us up production again. Now rather than having 3 people running CNC TIG machines, now we have 1 laser, and those 2 people that were out there are now in this building running more parts. Much more attention has to be paid to very, very minute details when it comes to suppressors and precision rifle. In some cases, the sound itself, even though this sounds amazing, isn't necessarily the best performance metric for a precision rifle suppressor. Where along the process is your QC? So as that laser comes down, we actually have a camera in there that is measuring the length of each of these parts. So if you get a short or a long part, it will kick this and not weld it and say, there's a part in this assembly that's bad. So when it goes from step 1 to step 2 validates step 1. Yes, the whole way through. Step 3 validates step 2, yep, step 4. The whole way through. So we're gonna switch products here. This goes in, this comes out. So that top one there is what it starts, and the bottom is what it finishes with on this machine. Have you, at some point in your career at Thunderbeast, run every one of these machines as like your day-to-day function? I program all of these. Oh, okay. Well, that answers that question. So we do concept, R&D, development, testing, manufacturing, processing. We write the programs for the machines. We spec out the machines. We put the machines together, and we basically do any SOP of how to run the machines. Okay. So we're the full turnkey engineering staff. So you're a part of the reason that Thunderbeast cans were so good. One of the many people of why they're good. Yep. So your Ultra 9, that was the very first can I ever designed. Really? Yep. Well, that can's awesome. So thank you for it. So we're required to put a length spec on the form for every single can. That length spec it's rather critical per ATF black and white rules. We have a prompt. When they hit cycle start, they measure the can, and it needs to take 15 thou off to meet ATF spec length on the form. So they put it in there, it probes it, it says how much do I need to cut off? They type in 15 thou, they hit enter, it cuts off 15 thou, and then cuts that exit profile into it. And then they flip the can over in the same machine, change programs, and we go from this to this. And at this point now, this is a suppressor. It's a fully done product. So at this point it isn't, at that point it is. Yep. Suppressor part, suppressor. What a lot of people don't realize is that bullet stabilizes in about the first 12 inches of flight, right? So when that bullet comes out, it's not spinning like this, it's yaw, right? Yeah. So a bullet doesn't have to hit a baffle to be affected by it. So if that bullet gets too close to a baffle, the pressure that it induces between the bullet and the baffle can cause that bullet to yaw in a slightly different way.
And that's going to change your BC.
On that specific bullet.
Yep.
On the next bullet,
it could be even different.
Right? So that's what can cause vertical dispersion as you start reaching out further and further. That's part of the reason we do this process. So we do the run out check on every single can so that we know that when you screw it onto your rifle, if it's a half-minute rifle before, it's a half-minute rifle with our can. And that's what allows us on a 9-inch can to have a run out at the end of it of 1.5 thou. So that means that that bore is less than 1 thou off of being absolutely perfectly straight. So that's a third of a thickness of a piece of paper within being absolutely perfect. And every single can gets...
Every single one goes through that.
Goes through this process check right here.
So then we're done with the run out test.
Yep, so now the only thing left is blast and paint. So blast and paint's super simple back here. So these are the cans that are yet to be blasted. Those are the cans that have been blasted today, and then all of this will get painted and boxed up. And then tomorrow we'll wheel more carts back here and start all over again.
You ever come back here and just like get a, you know?
Obviously not.
What is this?
This is the machine that started it all. This is the very first machine Thunderbeast bought to do prototyping, and we actually ran production parts on this machine at first. And this is the machine that the majority of our prototypes are cut on. So this is where pretty much every suppressor model, design, concept that Thunderbeast has ever made started here.
Some of those testing procedures that you guys saw are well above and beyond what your typical suppressor manufacturer is going to do. And that's because Thunderbeast focuses mostly on the precision rifle crowd. Again, those small little tolerances, those small changes that at extreme long distance can be big problems are really what they pay attention to.